Alright, so the heading is Index Laws with Algebra. The day is the 26th of March. And let's recall, what is this? Okay, so, Index Laws. You may remember, we dealt with index laws, but I said, laws, that's not the best word for what these things are, right? I called them shortcuts. Shortcuts. And we learnt 5 of them. It was the whole idea that, you know, when you multiply numbers over and over again, that's what you use indices for, right? But if you can understand how to work just with indices and not have to worry about, it's about multiplication, you can do things so much faster, okay? So, examples that we looked at. If I said 2 cubed, right? And I multiplied it by 2 to the power of 5. We're going to take these two numbers. The reason I can actually put these together is because they have the same... Well, this number here, we have a name for this number. It starts with a B. Does anyone remember? Yeah, Nathan. Base. The base, very good. It's the base because it's on the bottom, okay? So you got the bases, they're the same. So we put, as we said, the little numbers, which also have a name. What are they called? They got a few different names, right? We could say, yeah, Adam? Powers. We could say indices. We could say the really super technical name, the exponents. Okay, all the same thing, okay? We can add them together. So this is 2 to the power of 3 plus 5, which of course is 2 to the 8. Okay?
Don't you have to also do the 2 times 2, which makes it 9?
Okay, now, excuse me. I've done everything I need to here. We can double check it, we can verify it by remembering what these powers mean. Okay? And then we can see whether we need to do that. So 2 cubed, what's it a shortcut for? What's it an abbreviation of? Somebody hasn't said anything yet. Manal, yeah? Great. 2 by 2 by 2. That's 2 cubed, right there. Okay? In the same way, 2 to the power of 5 is going to be 5 of them, right? So 1, 2, 3, 4, 5. Done. So I've written all the 2's out. As it were, I've kind of expanded it. And you can see I've got 1, 2, 3, 4, 5, 6, 7, 8. 2 to the 8. Okay? Happy with that? Does that make sense? So we learnt this shortcut that you can add the powers. Those weren't the only shortcuts. That was just the first one, okay? Can someone give me another one? One very similar to this one, but maybe in reverse. Any takers?
Daniel was the taker.
Daniel. What if I write this? Let's try this one together. 3 power 4 divided by 3. This is a bit sneaky, but I think you guys can handle it, okay? Before I do anything to it, any operations, there's a number that's hiding there. I haven't written it, but it's really there. Anyone, any takers? What's hiding? Yeah. Okay, good. So this 3 is really, there's one of them. So it's really 3 to the power of 1. Okay, so I'm dividing instead of multiplying. So what's the shortcut I can use here? Brandon?
Minus 4.
Good. I'm gonna instead of adding, I'm going to subtract. So 3 to the power of 4 minus 1. So it's 3 cubed. Okay, good. Now we had a couple of other ones, right? 3 more, actually, right? And just to remind you, okay, if I take any number, let's go back to 2, excuse me, and raise it to the power of 0. That was a bit weird and unusual, because like multiply it by itself 0 times, but we looked at it, we thought about it. What was the conclusion we drew? Yeah, Adam, it's 1. Fantastic, okay? And a very similar one, if I have 0 not in the power, but in the base, right? If I have 0 to the power of anything, 2, 3, 4, 5, 6, 100, okay? What's it going to be equal to? Yeah, 0, good, because it's just 0 times 0 times 0 times 0, and it never amounts to anything. Poor guy, okay. One last law that we learned. Does anyone remember what the last one was? This is the trickiest one. Yeah, Nathan.
So I don't really understand why that's 1.
Why this one is 1? Okay, I'm going to ask you to go back to your previous notes on it. If it still doesn't make sense, you can watch the video. If it still doesn't make sense, you can ask me again. Or ask a friend. Alright, last one. Yeah, but no. Or did you have a question? Yep.
It's when you square or like put it to the power and you put it in brackets.
Yeah, great. Okay, so let's take that exact example. So here I've got a number squared, right? And then I'm going to raise that whole thing to another power. Okay, maybe something like, say, 7. What do I do with these numbers? I added here, I subtracted. Someone hasn't said anything yet. Someone who hasn't contributed yet to the group. Yeah, the
Multiply.
Okay, fantastic. I added, I subtracted. Now, these guys, right, it should be 5 to the power of 14 because it's 2 by 7, right? So 5 to the power of 14, well, that's going to be a pretty big number. Okay, that's what it's equal to.
Yeah.
Now, all of this is with actual numbers, but where we're going to progress to in this exercise is using these shortcuts with algebra. Right? Using these shortcuts with algebra. Let's give these a go. And remember, these are things that we're familiar with, but we just want to get really, really super comfortable with and really quick at them. Just like tying your shoelaces, okay? Make it automatic. This one here, right? I don't know what B is. It's algebra, isn't it? Okay? But that doesn't mean I can't understand it and work with it, right? That's the whole point. Even though I've got these laws here applied to numbers, these B's here are also numbers, I just don't know what they are. Okay? So I'm multiplying, so which shortcut am I going to use? Yeah, Rachel. Fantastic. It's the first one because it's multiplication, right? So when you multiply numbers, same base, but different indices, you add their indices together, don't you? So that's going to be B to the power of, now you can do it all in one hit, but I think it's helpful if you write it out as 4 plus 10 plus 2. That's more instructive to you and to me to show that you know where that 16 comes from, right? It's because I'm adding all those numbers. Okay, now in the same way, let's have a go at this. Now, I've chosen this one, number 1, because it's division, not multiplication.
And it's hard.
Number 2, it's a bit trickier because there's more stuff in there, okay? Now, when we were having a look at terms yesterday? Day before. Anyway, previously. You see, I've got numbers here, so I'm going to deal with the numbers first, right? I've got 18 divided by 6 times tables. 18 divided by 6, 18 divided by 6 is 3, right? So I'll write down a 3. So I've dealt with the numbers now. And then I'm left with these unknowns, p to the power of 7, p to the power of 3, and I'm dividing. So which shortcut? Yeah, Brandon.
So firstly,
Hold on. Answer the question. Which shortcut? Which shortcut?
shortcut number 2.
Good. Be really familiar with them. Perfect. Okay, so now what do I do?
And now I have to cross out the piece because I can't do that.
Okay, now, I'm going to cross out some of them, but not all of them. And I'll use the shortcut to know how many. Okay? So it's not like this p just disappears and this p just disappears, and it becomes to the power of 7 to the power of 3. Okay? I'm dealing with the numbers first, done. And now I'm dealing with the pronumerals. Okay, Ethan.
You need to cancel out 3 of the p, so it's now p4.
Fantastic, right? Now just to be a bit more instructive, right? That 4 is 7 minus 3. 7 take away 3, right? Because of this shortcut that we learned before. Okay? Of course, if you wanted to, you could write out 7 p's here and 3 p's here and then cancel them all out, but that would take forever. Use a shortcut if you can, right?